Funding for This Is Nashville comes from you, our listeners, and Alliance Bernstein. Since 2019, employees have impacted our community by giving more than 5,000 hours of volunteerism in Middle Tennessee. AllianceBernstein.com. Alliance Bernstein is not affiliated with National Public Radio.
I'm Khalil Ekolona, and this is Nashville. Okay, let's be honest. If you went out and talked to a group of third graders right now and asked them, what do you want to be when you grow up? You probably wouldn't expect many or any of them to say, I want to be a chemist. Well, that's exactly what Dr. Stephen Townsend said when he was 9. He held on to his dream, following it all the way to a PhD from Vanderbilt University, a postdoc at Columbia University, and then eventually back to Vanderbilt, where he's currently the Stevenson Professor of Chemistry. Dr. Townsend's lab, quote, cares about why people get sick and uses chemistry, organic chemistry, to find ways to help people everywhere get and stay healthy. He's currently leading the study of a chemical makeup of human breast milk. A few years ago, he discovered a new class of sugars in breast milk that prevent babies from getting viral and bacterial infections and which could improve the medicines for all of us. The applications of his work don't stop there, and they're pretty incredible. We're excited to have a chance to speak with Dr. Townsend to learn about his work and his life. Steve, thank you for being here. Welcome to This Is Nashville.
Oh, no, I'm happy to be here, and that was the kindest introduction I've ever received.
Oh, hey, that's what we do here. We welcome people with open arms. Okay, we got a lot to talk about, but I want to get started with your work. You're a chemist. Let's go big picture. For those who don't know, what is chemistry and what do chemists do?
Yeah, this is a fantastic question. I have 2 daughters, right? They both spend a lot of time on campus and in my office. And I remember my 5-year-old constantly asking me, what is chemistry? What is chemistry? And eventually she stopped asking me and I realized I got to the right answer. So, for Angela, I say chemistry is the science of the almost smallest thing, right? So if you think about everything that's around us, right, it's always made up of something else that's smaller than it. And so if you think about the thing that it's made up of, that's what chemistry is, right?
Okay.
If you say the smallest thing, then you're at physics, right?
Okay.
So we're at the almost smallest thing.
Okay. And so chemists study the almost smallest things in the world and how they interact and bond or repel each other.
That's right. Yeah. So we build new materials, we make new medicines, but everything is at, the so-called molecular level that you can't really see, right? Until you build it up into something bigger.
What do you love most about being a chemist?
Yeah, when you think of life's hard, right? And we don't always get to control everything that goes around us in life. But in chemistry is 100% control. So if you want to manipulate a system in chemistry, you can do it. You can force something to do exactly what you want and get the outcome that you want, hopefully. Yeah.
Feels kind of powerful.
It is powerful, right? You feel like a warlord sometimes.
Okay, so give me, what's the most dangerous chemical experiment you've ever undertaken? Something that could blow up the old school Bunsen burner beaker style.
Yeah, well, that's exactly it. So we use a lot of solvents, right, in our day-to-day work. A lot of people have probably heard of ether. My great-grandma remembers getting dental surgeries where they use ether to put her under, right? And so, one time I had some ether going. I had a Bunsen burner going to the left of it, and the ether caught fire.
Wow.
Right? So this is sort of, chemical safety is something that we take super serious. And I think just the use of solvents every day, we use a lot of hot materials. We use a lot of open flames. And so there's a chance that anything can catch on fire at any time. So you got to just always be, of utmost highest safety.
Okay. Well, talk to me about your study now. What do you currently study?
Yeah. So, in the lab, we have multiple projects. So we have the Human Milk Project, which we're probably going to talk about today. We're also interested in substance use disorder. So how can we help people not be addicted to really nasty substances? We also have a project that's focused on cancer. So, if I take a step back, I would say whenever I think about what projects we work on in lab, they always really start with people, right? So what is affecting the families of the people that are in our group? If there's any type of ailments or illness, can we actually use chemistry to try to help people's families?
Where'd that curiosity come from?
Yeah, I think my mom really mined the curiosity. Think about growing up in Detroit. She was a single parent, 19 years old when she had me. I was running around the house reckless all the time. Let me mix this bleach with this washing powder. Let me go outside and dig this hole and pour some lye in it. So at one point she told me, I think you really like science, but let me try to harness this so that you don't, set the house on fire. Right? So that's where it started all, just from Frankie Townsend trying to harness the energy of her kid.
Okay, I had I had an interesting chemical experiment go off, unbeknownst to me. In the house doing laundry, decided to consolidate, get rid of some bottles. So I took some of this popular stain remover product that's out there and mixed that in with my detergent and closed it and thought I'd be fine. I heard an explosion about a half hour later.
That's right.
And that bottle blew up. And I was like, whoa, I didn't even know. We have all these chemicals that we have in our house, in our homes. What is it like to be a kid and to grab all of these different elements? You have no idea how they work together, but you're curious to see what you can come up with these type of chemical compositions and compounds.
Yeah, it's fantastic, right? Because, everything starts with sight and smell and touch, right? And so you start to, you see this bottle of bleach, right? It tells you don't touch it, don't mix this with this, don't pour this down the drain. And, as a kid, you're wondering, why is that, right? So your inclination is to go counter to advice. So for me, I would just go around looking for things that say, don't mix with A, don't mix B with C. Okay, let's find out why. So let's mix B and C. And then after that, you get a whooping and you're like, all right, maybe I won't mix B and C again. Right?
You ever start a fire accidentally?
Yeah. I don't have enough fingers to account for the amount of fires that I've had in my life.
All right. Okay, so you were recently featured in the video for the Vanderbilt Quantum Potential series, which Jad Ebenrad produced. Let's listen to a clip about your work studying breast milk.
How did breast milk become an interest?
The program really just started from a future dad just wondering about the food his kid was going to eat. We're in New York, so we're walking through Harlem, and we quickly noticed they were advertising formula and infant food products to people of lower socioeconomic status, people who were wealthy, inundated with breastfeeding resources. So I took an interest at that point, and for me, I could really tease apart at the molecular level why is breast milk special and provide that information to everyone. So everything starts right here in the lab.
Can you walk me through the various elements of so you have the milk, you want to know what's inside it?
Yeah.
This is Sabrina Spicer. She's a grad student in Steve's lab.
So you start with a whole breast milk sample.
Spinning it does what exactly?
So I don't know if you've ever ridden the Superman ride at the fair.
Mm-hmm. That one.
So centrifugal force, right?
Yeah.
Okay, so when you do that, all the fat will come to the top. And so you just scoop it off, looks like butter. And then you do it again until you're left with the milk sugars.
Women can make anywhere between 25 and 200 sugars, and they all have a design purpose for the baby. So what if a researcher could say, here's a molecule that does something really dope, can we now apply that to a problem that has nothing to do with breastfeeding? But it turns out that we can.
All right, you and your wife are living in New York. You see advertisements for formula, everything to steer women away from breastfeeding their kids. You get curious. When you first looked up what kind of research was out there on breast milk, what did you find?
Yeah, so that's a perfect sort of lead in because when it comes to designing any research project, right, the public may or may not know how an idea starts and really leads to a project and leads to open research. But yeah, we were curious about breast milk, and so I wanted to go find out what is known, right? Because for any project, you got to start with finding an unknown. It turns out from a sociology place, right, we know a lot about what breastfeeding does emotionally for mom and baby. Big picture, we know, if a baby breastfeeds, they get maybe less sick than a baby that formula feeds. But when we go down to the chemistry, I couldn't find any chemistry, right? There's very little that was known about molecular level, right? When we're talking about carbon, nitrogen, atoms, right, elements. So I knew, there was going to be some research that could be done on the chemistry side because everything was really on the biological side, on the sociology side.
All right, so collectively, we're better understanding the benefits of breast milk and breastfeeding, making sure that nursing mothers in public spaces have safe spaces to breastfeed their kids.
Right.
But people are still uncomfortable talking about it, thinking about it. Before you started your research, what did you think about breast milk and breastfeeding?
Yeah, and so coming out of New York City, it was a great place to really explore this topic because in New York, everyone's minding their own business, right? You can be on a subway train and you'll see 6 women breastfeeding, but really nobody is seeing them because it's New York City. There's 10 million people and everyone's minding their own business. From the perspective of being in New York, it was a great place because you could openly ask these questions, right? If there's a mom who just finished breastfeeding on the bench next to you, you could talk to her about it. How long were you breastfeeding? How often do you do it? And people are open to really talk about it. Now, depending on what part of the country you're in, though, you may not be able to do that. And so, right, it could be a little bit tricky sometimes.
What do you think about it?
Yeah. So personally, I thought it was phenomenal, right? I thought it was free, right? As a person who was about to have my first daughter, and I was like, man, breast milk's free. Formula costs a lot. So you want to know about this free, outstanding resource. And eventually I came to the conclusion if water is the most important liquid on earth, breast milk is number 2. So this deserves more research than it actually gets.
Were you breastfed as a child?
So I wasn't. And none of my siblings were. I was born in 83.
Okay.
So, my mom used to talk about when she gave birth, the doctors didn't even ask her, are you breastfeeding? For me, they just gave her a medicine, stopped her lactation, and said, here's some milk product, go ahead on home, right? So the option wasn't even presented to her. At that point in time in society, right, we thought formula feeding was better. And so oftentimes women got their choices taken away from them.
My mother loves to tell this story about me. I breastfed until I was about 4 years old. And she tells the story that her and my father were trying to find some way to wean me. They couldn't. They tried. So one day they made every milkshake, every ice cream delight. They even went to Carvel. If those who know the old school Carvels, they went to Carvel and got everything, laid it all out on the kitchen table, and we're like, here, son, you can eat all of this. I had 2 older sisters at the time who were very upset that I had all these sundaes available for my consumption, and I didn't eat a thing. It took them a minute to wean me off of that. Thank you, Mom, because I rarely get sick these days. What do you suggest how people think about breast milk and its benefits these days?
Yeah, if I would want to pass a message on to people, I would say breastfeeding is just a mom feeding her baby. Breast milk is just food. It's incredibly powerful, right? It helps starts the baby's immune system. It prevents illness. So breastfeeding is super important emotionally. Breast milk, from just a growth and development perspective, there's no more important substance. So, right, I think very highly of breast milk, and I hope the general public will too.
Well, talk to me about the steps, like from being curious about it to actually doing work in the lab. Walk us through the scientific process from curiosity to designing to actually running experiments.
Yeah, so the project started in New York when I was still a trainee, so I didn't actually have a job yet, and so I think that's one part about being a research faculty member at a big university is that they hire you to teach, but they also hire you to do really outstanding research. And so before you even start your faculty position, you got to figure out some projects that you might want to do. You then got to go ahead and pitch those to the universities, and hopefully someone's going to hire you. And then once you get hired, right, once I started at Vanderbilt, we hit the ground running. So, right, what do we want to research? Well, we knew that babies that breastfeed are generally, quote unquote, healthier than those that formula feed. They get sick less often. So why is that, right? And so we hit the literature and we started to figure out maybe there's components, parts of breast milk that are actually able to kill bacteria or kill viruses that might harm the baby, right? So then there you go. So we can sort of test the hypothesis. There are components in breast milk that keep the baby healthy by preventing, bacteria from growing or causing an infection. So then we need bacteria, and then we need breast milk. One of those, we found very easy to get. The other was hard.
Okay.
Right. So milk, how do you get milk is always the big question that people ask. Shockingly, our very first milk actually came from, I would say, a place where we're trying to turn a tragedy into a triumph. If you think about someone who gives birth and what happens if the baby sadly is born stillborn. So now you have a baby who's lost their life, but mom's still going to pump milk, right? She's going to produce. So our very, very first milk actually came from women in those types of tragic situations where they still had milk to express. And so now we can actually do something powerful with their milk, and it's not just going to go to waste.
Wow.
Yeah.
There's between 25 to 200 sugars in breast milk.
That's right.
Why that range? And do different bodies create different numbers of sugars? Hearing you say that breast milk can kill viruses, it feels to me like it's like a natural vaccine that we ingest when we're born if we're breastfed.
That's a great description. It's personalized medicine, right? So, to answer your questions, right, women produce different sugars based on their blood types, based on the timing and the stage of their lactation. So the sugars that you make on day 1 are probably different than those at 2 weeks, at 6 months, at 4 years. So yes, so it's really personalized. Mom makes exactly what the baby needs at that exact moment in time. Why so much diversity? Why 200 sugars? Evolution, right? So if we think about what these sugars do, we figured out that, yeah, on one hand, they can actually kill a lot of bad bacteria. But we know most bacteria aren't bad, right? The human body, tons of cells. For every one human cell, there's one bacterial or other microorganism, right? So we're at 1 to 1. A lot of those bacteria are really good and helpful. So the flip side of this coin is that these sugars in milk are able to kill bad bacteria, but they're also able to grow good bacteria. right?
Okay.
So this is like a fantastic evolutionary design, and you need a lot of different diversity to get that design.
You know, talking with you about this, I'm filled with so much wonder. Does this feel like spiritual to you to look into it? You know, when you look at the magic of evolution and how it adapts to what we need at the time, even if we're not cognizant of it.
Yeah, it's absolutely spiritual, right? It's soulful, and it makes you think, there's a great design and a great purpose to everything that we see around us. And I think that's part of science, just really teasing apart everyday phenomenon that we see, and we really don't understand that well.
Run some of the other applications of breast milk down for us that you've discovered.
Yeah, so where we're going now, which is I think is really phenomenal, is that we're basically trying to say what is known about what mom does through breast milk to protect her baby, right? So we know that there's brain development, right? And so we know there's development of the stomach tissues. We know there's like development of immune system, digestion. And so we sort of line all of those up and we say, well, what's the adult parallel, right? So if mom is able to put components in her breast milk that help with the baby's brain development, is it possible to take those components and maybe give them to an Alzheimer's patient, right, who's having neurodegeneration, right? If mom's milk is able to help the baby's stomach develop, can we take some type of adult stomach injury and then treat that with human milk components, right? So now we're at the stage of, finding a adult parallel to everything that we know that mom does for baby so that we can try to translate over.
Are there non-biological applications that breast milk can help out with?
There are. And I have a very, very talented summer student with me. She's originally from Detroit. She's now a student at Cornell here at Vanderbilt for the summer. And so she's working on this sort of gnarly, far out idea of biofouling, right?
What's that?
So that's when we, unintentionally, I think, pollute the ocean, right, with different types of materials, different types of microorganisms, bacteria. So if we think about, for example, this is a good example, the United States Navy, right? One of their biggest wastes is fuel, and it's because biofilms stick to their ships. And all of our listeners know about biofilms because we brush them off our teeth every morning. Mm-hmm. When those biofilms from the bacteria stick to the ships, barnacle and other garbage then sticks to the ship and it causes drag, right? And so if you cause drag, then you're wasting fuel. So I have this, fantastic student this summer trying to say, well, is it possible to take these sugars in human milk, create like a really nice paint or coating, put that on the ship, and then stop bacteria from sticking to it, stop biofilms from forming just like on our teeth, and then ultimately we can make ships move through the ocean smoother.
Wow. How far has that research gone so far?
So, she's right in the middle of it. So we know that these, if we take ocean bacteria, we do know that some of the sugars in milk will stop them from producing these so-called biofilms. So now we're trying to get the actual formulation correct, right? How do we actually get these sugars in the paint and then make that stick to a ship? And this is cool because it goes beyond that, right? If you think about someone who goes to the hospital and maybe you need a catheter, you're more likely to get sick in the hospital sometimes than on the street. Mm-hmm. And part of that is because these bacteria can form these biofilms on these little devices. It gets into your body, causes disease. What if we can coat a catheter, right, or some other type of device so that a bacteria can't do that? So this is where we're going, right? We have the sort of human side of it, but then always challenge the students to just think gnarly, right? Think far out. Like what's something that shouldn't even be possible that no one's ever thought of that maybe we have a new application for.
This is fascinating. We're going to take a quick break. When we come back, we'll talk with Dr. Stephen Townsend about his personal journey to becoming a scientist. Stay with us. This is Nashville.
Funding for This is Nashville comes from you, our listeners, and Music City Prep Clinic, Nashville-based provider for PrEP and offering comprehensive sexual health services in an environment designed to be safe, professional, and shame-free. Learn more at musiccityprep.org.
I'm Khalil Ekalona, and this is Nashville. Today I'm talking with Dr. Stephen Townsend, a chemist who's studying the unique sugars found in human breast milk. Dr. Townsend, again, thanks for being here.
It's great being here.
All right, so Stephen recently featured in a video for the Vanderbilt University Quantum Potential series. We're going to listen to a quick clip.
My name is Steve Townsend, and I'm a professor of chemistry at Vanderbilt University. I'm also a professor of pathology, microbiology, and immunology. I like culture. I'm maybe a closeted humanist. I dream molecules. A couple months ago, I ran my 10,000th chemical experiment in my life.
Wow.
I'm obsessive compulsive, so I know that.
Wait, you've been counting your experiments?
Yes.
Amazing.
Yeah, I come from a family of pseudo-chemists. My great-great-great-great-grandfather was the head chef at Wessington Plantation. My great-great-great-great-grandmother did localized medicinal chemistry to make herbal remedies. So they don't have a PhD in chemistry, but I would say they know how to manipulate structure.
Wow, so it sounds like chemistry's in your blood.
I was curious. So my mom wanted to expose me to as much chemistry as possible early on in life, but there weren't a lot of books in the 80s about Black scientists. So by second, third, and fourth grade, I was the world's leading expert in Louis Pasteur.
Get out.
That's pretty cool. You dream about molecules. That's interesting. Like, do you see them in your dreams? You talk to them? What are these dreams like? Describe one for me.
Yeah, I think everyone has had these types of dreams. So I'll dodge your question for a second to give you a parallel example. So both of my daughters draw these pictures, right, just like everyone else's kids. And they draw these characters that are terrifying. And so, every now and then you stare at a picture long enough, you go to sleep and you see these little characters from your kids drawing, chasing you around.
Okay.
The parallel then is chemistry. So, right, you think about chemistry so much and I visualize things in 3D, right? There's chemicals floating in front of me when I'm thinking about the problem. But man, that translates into the dream. So, I remember being 24 years old, graduate student, ready for my PhD candidacy exam, major milestone. And the night before, I have molecules just chasing me around in my dream, right? They were shooting me with arrows, and I'm just like, what's happening here, man? It was gnarly. I couldn't wake up, but that wasn't an isolated event. This happens all the time. So I would say, of 7 days in a week, 2 nights I have, chemistry-related dreams, and there's like inanimate objects that have become alive, and they're chasing me and tormenting me, and I don't know.
That's pretty fascinating. I could see, some people would be like, oh, you're too obsessed with it, but to me, it feels like you were meant to do this work.
Yeah, I hope that's the case. And, I think a little bit of obsession is okay, right, when it's sort of pointed in the right place.
Yeah, I hear that. Now, you told us how you got onto chemistry as being the oldest child for your mom, mixing all these experiments in the house. And she led you on a course of study. You're the oldest of 5 siblings.
That's right.
And you have said that your mom played a super important role in your overall education. How did she do that to support your interest in chemistry as you grew older?
Yeah, from the earliest stages, I remember my mom telling me, right, I know I need to read to you as a kid, right? It's very important to read to you. I don't want to read these kids' books, so I'm going to read you Soap Opera Digest, right? I'm going to read to you the Detroit News for that week. So, early on, it was just like constant, nonstop reading. And I remember her telling me, I was like 5 or 6 years old. She's like, anything that you ever encounter in life, somebody's already encountered it and they've already written about it in a book. So the more books you read, the more knowledge you're going to have, and the easier you're going to be able to navigate any future problem. Right. So I think, when I think of direct chemistry influence, she knew she wanted to harness this interest that I had. But beyond that, it was just really a life skills sort of a thing that she did with me, right? She just taught me how to navigate life and how to really solve any problem that I can encounter.
I want to talk about school. When you were younger, you had this interest in chemistry. Was it something that came naturally, or did you have to work hard to grasp it when you were in school?
Yeah, so, without sounding arrogant. So school's never been a problem at any stage or any level for me. I remember being in 4th grade in Detroit, and, there were days where I didn't have any work. And, I had a cohort of buddies, one good friend, Larnell Collier. We didn't have work to do, right, because we had made it through the units. And so we just ended up screwing around in class, being loud, sort of upsetting other students. So I would say, when it comes to the educational component, sadly, I've never had struggles in that area. But when it comes socially and being able to harness, my attention and sort of keep pushing forward, not distracting other people, that's more where I struggled in school. And I think a lot of students have that same issue.
How'd you help yourself overcome that issue?
I remember, my first job, I was 13 years old. I was working at a car wash. And I remember that was around the time where I started to become a man and grow up. And, I had the ultimate sort of lesson that my mom gave me. She sent me down south. Right. And so that was when I first encountered Wessington Plantation. My great uncle, who's written a book about the history of our family, really took me around and showed me what they went through back in the 1800s and why I need to make sure I do right by them. right? And so it was really being sent down to Tennessee, understanding the institution of slavery, and then personally knowing my ancestors. And I'm like, okay, right, I need to just focus, right? If I'm done with my homework and I'm in class, then I need to do more. If I'm in the 6th grade and I've done the entirety of the math book, let's go find the 7th grade book. So for me, it was always, let's push forward to the next most difficult task, because I got people who did a lot of hard work for me, right? And I need to do right by them.
So understanding more about your family's history and respecting and honoring that legacy, you applied that to your approach to school. From what I understand, you took this unusual approach that a lot of other people don't take when it comes to classes, particularly in college. You took the hardest possible classes you could at the same time. That is, for anyone who went to college, you understand, you're taking 18, 21 study hours of some really tough classes. That's a hard semester, and you did this continually. What were you after?
So I love Detroit, but I was after not going back to Detroit. Right. And, you got to respect education. Education will take you places that you could ever imagine. Right. 2 weeks ago, I was in France. 4 weeks ago, I was in London. And so I knew, right, I needed to take advantage of the opportunity that I had in hand. I wanted to learn as much as humanly possible, and I was going to go after it. So I took a lot of very, very difficult semesters because I just want the knowledge. You got 4 years. The education, right, the taxpayers helping pay for it with the Pell Grant. Right, there's a lot of people investing in me, so let's go after this now to the max and do what we have to do.
It's an interesting mindset. Where'd you get that from?
Yeah, I'm an athlete. I'm competitive. I mean, it's a perfect storm of just someone who, I don't know, man. I'm wicked, right? So I just always want to win.
Okay.
Right, and I think, the more knowledge you have, I'm not LeBron James running down the court at age 40, but I am, 41-year-old scientist who wants to be in the National Academy of Sciences, right? And I don't want to wait to go to the National Academy of Sciences when I'm 60. I want that tomorrow. So I think I've always had that mindset of how do I get to the big times as quickly as possible, and I think that's through doing hard things.
It's kind of like the athletic mindset. Who are some of the athletes who exhibited this mindset that you kind of, modeled yourself after?
Yeah, the number one is, my fraternity brother, man, Jerry Rice, right? So, you go and win the Super Bowl. Everyone else is celebrating at the bar. Jerry Rice is running up and down the stairs in the stadium, catching passes from the cleaning crew, right? So I think, if you look at Jerry, you look at a Serena Williams, right? You look at a Michael Jordan, a Kobe Bryant, they all have that same winner's mentality where you just don't take breaks. You just keep going after it so you can keep getting better.
If you're just tuning in, this is Nashville, and I'm your host, Khalil Ekolona. We're talking this hour with Dr. Stephen Townsend, the Stevenson Professor of Chemistry at Vanderbilt University. All right, pressure. There's a lot of pressure on and in academic fields. You worked your way up to a PhD, a lot of steps in that process. You eventually went through getting tenure. How have you managed the stress and the pressure over the years? Have you seen a change in yourself and how you operate?
Yeah, early on I managed the stress very poorly. I like to tell people I'm the world's best ruminator, right? If something happens, there's nothing that I can't just fixate and obsess over to my own harm and detriment. There's benefits to being, 41 now and being in your upper 30s. You sort of learn life's lessons. What I learned is when I'm in a pressure cooker, right, it's important to just stop and think. You got to, ask for help because there's always help there. You just got to be willing to ask for it. And for me, it's just really being logical and breaking down the problem. What can I control? What solutions can I come up with by myself? And where do I need help? But, before 35, 36, I didn't know that. And I would just stew and I would lose sleep and I would have to get up in the middle of the night to pee 15 times. But at some point in life, you start to understand life. And, I was just really appreciative of time and experience.
How do you share those lessons with your daughters?
Yeah, Allison Townsend, man, I tell her all the time, you keep making these mistakes that I've already made. If we just have a conversation, I can give you the special sauce, right? But there's also a part of life where we have to screw up ourselves, right? So I just try to explain to them, there's some things that you're going to experience. We already know the solution, but there's some mistakes you're going to have to make yourself, and we're here to help you rebound.
So your daughter's pretty headstrong. She's going to do it. She's going to discover for herself, she kind of feels like.
There's no question. We have this thing now because she's almost 11 where, she likes to make play dates for herself. And she tells us about this play date the day before. And we're like, well, dad has class, mom has this event. There has to be discussion. You're 11. You don't get to make unilateral decisions.
I wonder what those discussions are like.
When I think about it, most of the sessions in my house, right? Because I'm sort of isolated as the only dude. I'm quiet a lot. Right? I play referee. I try not to get in the way. But yeah, the discussions actually are peaceful because my daughters, as much as I joke about them, they're pretty compliant, right? And when they're not compliant, I'll give them credit. They're often justified and right.
Okay.
Yeah.
I want to look back and look forward. Like when you talked about 24 years old going for your postdoc, did you imagine you'd be here right now?
For as sad as it is, for most of my life, I didn't think I would be alive past 25, right? So I was never a person to ever get in trouble. That just wasn't my game. But if I think about every man in my family, with the exception of, myself and two uncles, everyone has served significant time in prison, right? So I remember, it's sad, man. Every birthday I would, sort of like say a little prayer, thankful for being alive, because I always had the statistic, before 25, you will either be dead or in jail.
Yeah.
And I was like, well, I'm not going to jail. I visited there enough times to know, like, not doing that. So I literally thought I was going to be dead by 25 just as a consequence of growing up in Detroit. So where I'm at now, family, career, I never pictured this coming, right, until, post-college.
Yeah. I mean, I grew up just outside of Baltimore, but I know for young African-American men growing up in Baltimore, life expectancy 25. Same thing, Los Angeles, same thing, probably down here in Nashville in certain areas. When you look at that, like that is the motif. That's what we can expect as young black men growing up. You're 15, 16, 18 years old. You got 7 years left,
Right.
When you think that is the motif, that is the expectation for us, some people try to live up to that, and other people eschew it, like yourself, and go on to do great things for the community. What is the preferred mindset you'd like for young African-American men across the country to be given? What is that preferred motif how they can look forward to living the rest of their life?
Yeah, I think everyone should understand that for your life, you should have just a high standard of excellence and you should pursue achievement. I remember when I graduated from high school principal said, this is a great day for all of you, but for none of you, this should be the best moment of your life, right? And so I want, people to think past 25, right? Think, how can you harness your skills to be the best version of yourself and ultimately achieve something great for yourself and your community, right?
Have you seen in your work, particularly working with students, have you seen more like young African-American men or women or just women in general, anyone get involved and interested in the sciences, in high science?
Absolutely. I saw it, I guess, 2 or 3 days ago. So I went to give a seminar about black professionalism to a group of, I guess they were 9th to 12th graders, just randomly selected from the Nashville Public Schools. And, these kids, all of them were interested, right, because they're there. They want to know, like, how can I better my life? But within that crowd of 15 to 20 kids, there was 4 who I knew, oh, yeah, you're the next person, right? You could tell there was a hunger in their eyes. They were asking the right questions. How much does graduate school cost? Right. You wouldn't think many 17-year-olds are thinking past undergrad, but they're asking how much does it cost? Well, I'm glad you asked, because a graduate education in STEM is free. You don't pay for that, right? The taxpayer has your back. A faculty member will pay your stipend and your tuition through grants, right? So that I've been meeting kids every time I go out into the community that are already asking the right questions. And so I think, right, we're turning in the right direction, but there's still a lot of hopelessness.
How can we battle that hopelessness, change that hopelessness into actual hope, into action?
Yeah, so I think it starts with active researchers going back out into the community, right? This isn't a problem at the level of the kids because they can't control much. But I think when you have researchers, I'll use myself as an example, right? How you see me now is how they see me every day on campus. Jordans, gold chains, gold earrings, tattoos. So I look like the 40-year-old version of all these kids in North Nashville. Now, when they meet me and we talk and they understand what I do, that opens up one door. Okay, he looks like me and I can do what he does, right? So I think this really needs to start, I think, from the top down, where it's more researchers going out into the community, showcasing what we do so people understand, a scientist isn't this old, 80-year-old person in a lab coat, right? There's no one face of science anymore. It can be your face.
Do you think social media can help spread the message of the benefits of studying in the sciences?
Yeah, there's no question. I got a buddy, Andre Isaacs, who is probably one of the biggest personalities when it comes to science social media. He creates different TikTok videos, right, in his lab with the students, right? So it's just dance move central. And am I going to do that? No. But I think, for the current generation, it's a powerful tool, man, because you can easily just spread the word. People can, maybe if you're in North Nashville, you don't have ready access to a scientist, but you can easily go online and find them through social media because it's so huge at the moment.
Let's take one last break. When we come back, we'll turn our attention to how Dr. Stephen Townsend approaches mentoring other scientists and how we can all up our scientific literacy game. We'll be right back. I'm Khalil Ekalona, and this is Nashville. Today we're talking with Dr. Stephen Townsend. He's a chemistry professor and researcher at Vanderbilt University. Dr. Townsend, again, it's good to have you here. RK, you're super busy, very busy. On top of research and teaching classes, as you mentioned before, you're traveling across the world to speak on your work often. You have a family, 2 young daughters, but you still make it a point to reach out to the youth, talk to community about science. Why is that so important to you?
There was no one to do that for me until I got to high school, right? So I think about, this sort of amateur chemist, right? I had, Frankie Townsend doing the best that she could to sort of direct the attention to the right way or to the right place. But ultimately, it wasn't until 10th grade until I met Mr. Cuba, who was my chemistry professor, that I really had someone show me what a chemist could be and what that looks like from a professional level. So Mr. Cuba was the first sort of like stone or first domino. After that, I got to college and there was Amanda Bryant Friedrich. So she's dope. She's a Black woman. She's now the dean of the graduate school at Wayne State. So she was my undergraduate research advisor. And, she really pushed me on the path to say like, all right, you can achieve far greater than I've ever achieved. And it starts right now. Right. So I think, I do that because of Mr. Cuba, because of Amanda, all these people along the way who've really just like helped me. And you never understand why people help you. Right. And I stopped asking that question a long time ago. I just know that it's part of my duty to go out and help.
Can you tell me a story of a young person you talked to when they were maybe in high school or middle school who's turned around and come back to you and like, hey, I'm getting my PhD in chemistry or sciences now?
Yeah, I mean, I can. So if you give me 1 year of grace, I can tell you about Isaiah Spate.
Okay.
Who was one of my first undergraduates when I started at Vanderbilt. He went to Norfolk State University, so HBCU. Isaiah, since I met him 11 years ago, has gone on to finish his PhD, finished a postdoc, and he's now a professor at the College of William and Mary. So yeah, I have this long list of people who there was an initial meeting, right? We got together, right? Some type of training or mentorship, and then ultimately they're at a position that's much greater now.
How would you work it when, you had a student who would say, okay, chemistry sounds cool, I'd love to study it, but man, my chemistry class is really hard. It's kicking my butt. I want to get good grades, but I don't know what I can do. How do you convince them to maintain, to push through so they can remain on this track of chemistry?
Yeah, so I'll bring up another student. I had a great, really talented student, Jair Powell, who's now in graduate school himself. He's a Chicago guy. Jair, I remember when he came to my lab, he was like, man, I'm getting torched in my chemistry classes. I need help. Like, how do I do this so that I can keep on the track of going to graduate school? In that case, I was like, we got you, right? So when you want to do well, there are people who are going to support you. I immediately paired him with a talented graduate student in the lab. Every day he would come in, instead of just running experiments, he would do his homework in the lab, right? And then there were students who've already been there, done that, and they helped him. And so eventually we got him to a super, super high level, and he was able to go pursue his dreams. To me, I always try to tell students, it's hard to convince them, you never want to fail a class, but ultimately the grades are not important. This is a knowledge thing. Grades they're not real. They're a construct, right? Yeah. They're a way to compare apple to orange. But really what you want is just the knowledge. And if you can get the knowledge, right, people will find out and they'll help you push forward.
Why do you think so many people struggle with chemistry?
Because I think there's just too many poor chemistry instructors. Right. And so, I know a lot of phenomenal scientists, right? People who are on the cusp of maybe Nobel Prizes. But if you introduce them to some random person on the street, they can't explain to them what they do every day. So I think this is a problem of just science literacy, but it's from the top. The inability of scientists maybe to explain what we do on a day-to-day basis to everyday people.
What do scientists and the scientific community, what do they need to do better to communicate that to everyday folks?
Yeah, I think if people can get out of the weeds, right? If I think of like what comments I hear about a lot of scientists on my day-to-day life, is that people are too far in the weeds, and when they try to explain something to you, they lose you before they get to the third word, right? But if you can sort of come out of the grass and get this like 30,000-foot viewpoint, my mom knows what I do, right? She didn't finish high school, but she'll tell you, yes, Steve cares about why people get sick. Here's the 4 programs that he's working on. These 2 are supported by the NIH. I now know what the NIH is, and he explained that my tax dollars go to support that research, right? So yeah, I take everything at the 30,000-foot viewpoint because that's where you're going to pull most people in. And then for those who want to know more, you can take them down to 20,000 feet, 10,000 feet, and start giving more information. But really, it's like just getting big picture messaging correct.
So it sounds like, the scientific community should message to people in this big picture view, kind of like what Neil deGrasse Tyson is doing in certain ways.
Yeah.
How do we need to change our thinking on the education of science and how it's applied?
Yes, I think, we need to, there's a lot of ways to answer this question. So, I taught for the first time this class is basically chemistry for everyday living, where I was like, what are some important chemistry-related topics that people would be interested in but probably don't know a lot about at a factual level, right? So I was talking to them about just drug production, right? Illegal drug production.
Mm-hmm.
Why is it that when you go to CVS and you want to get some Sudafed or something that you have to give your ID? What's happening with these matches that were stolen or these batteries that were stolen. So to a group of non-science majors for the entire semester, I taught them about, we call it clandestine drug chemistry. Chemistry is going on in people's basements and backyards, right? You see it on the news, you know it's occurring, but you don't know how it's happening, right? And so we navigated this entire course. It was a phenomenal experience. But again, that's an example of giving people what they want when they want it in real time. And that was a topic people wanted to know more about.
When you talk to young people, how curious or interested are they in sciences, particularly chemistry?
Yeah, they're amazed, they're astonished, and they're right in immediately. And the classes end up, right, the discussions go beyond chemistry, right? Because we're talking about all of the stuff that's happening, and then students start asking, but why? Why is there a demand for methamphetamine? Why is there a demand for cocaine? So now we can go talk about a different issue. This then leads us to some sociology. Maybe then we're talking about sentencing. So now we're in political science and criminal justice. So I think, these are inherent topics that people see every single day, right? What's the difference between a generic and a name brand ibuprofen, right? People want to know this information. And, if you're willing to teach it, they're willing to learn.
So it'd be important, like in health classes, let's say, to incorporate science and chemistry. You're going to be taking these things into your body, understand fully how they interact with your body and what they can do to it.
Absolutely. You think you hear this all the time, right? Mexican Coke tastes better than the Coke we get in the United States. Well, let's teach people how to read a label so you can understand the difference between sucrose and high fructose corn syrup, right? Why do they have different mouthfeels? Why is one, sweeter than the other? Yeah, so these are all things I think people could use every single day that they don't get enough of, certainly at the university level, but definitely not at the K through 12 level.
Mm-hmm. All right, so we found a quote of you saying, quote, "I'm a scientist and we do whatever it takes to answer a question." In science, the work is to answer questions. You spend part of your time explaining that to the public. Do you think that most people really know what scientists do? Like, is our science literacy as a general public on the up and up?
No, I think it's very poor, especially when I go to other countries and see what the general public knows there. So I think, if I could tell the public what we do on a day-to-day basis, we're just trying to answer questions about things that we don't know, right? That makes for the best research project, something that's interesting to you, that you don't know anything about, and that the world generally doesn't know about. There are some scientists there trying to answer the question, right? And so, yeah.
If you're just tuning in, this is Nashville, and I'm your host, Khalil Ekalona. We're talking this hour with Dr. Stephen Townsend, the Stevenson Professor of Chemistry at Vanderbilt University. Okay, I don't have training to be a scientist, and I've forgotten maybe a couple steps in the scientific process. Some people never even really learned that when they were in school. But that doesn't mean we can't learn more about science and up our science literacy. What are some of the everyday ways we can learn more about it?
Yeah. So, I have a neighbor down the street. He tries to out-garden me and out-compost me every day.
Okay.
So, he has some tomatoes, and he was like, Steve, man, my tomatoes have blossom end rot. So people know what that is, right? If you turn over a tomato and it has black rot on it. Mm-hmm. So he was like, I was on Google, and I found out that, like, maybe if I drop some Tums, crush them up, put them in my plants, water them, then, like, that's going to, like, maybe help with the rot. And so he went out and tried this and was successful. So what just happened there? Well, he started with an observation, right? He then went forward and, did a little bit of research on his observation, formulated a hypothesis, tested the hypothesis, and then came back with a conclusion. So I think, the general public, right, all of us are scientists, right, because we're just always all trying to answer questions. And at this point in human history, right, research is at your fingertips with search engines. Mm-hmm. So I think, we're all scientists. And, if you want to learn more science, it's all around you, right? Citizen science projects are just bountiful at this point. I tell people all the time, if you want to do science and you're not trained to be a scientist, call Vanderbilt, right? Call us. And right, I've had people call General Vanderbilt hotlines and make their way to me to ask a question about breast milk or antibiotics, right? So I think the resources are just plentiful. And then if you just don't know how to find them, contact your local university.
You said search engines. Should I just go type up something on Google, or are there specific sites that'll help?
Yeah, so this is a phenomenal question. So .gov sites are great. These are government-based sites. So these are, legitimate sites where people have done research that's peer-reviewed. Other people have checked the data. .edu is coming from universities. Again, peer-reviewed. It's not just one person saying, I have a finding. And so beyond those two, though, I started to get a little bit weary. There are some .org sites that are great, but not every .org is an organization that's trying to help people. So I like federal government websites, and I like university websites when I look for my data because, right, those are validated, useful resources.
Sometimes in thinking about it, science can become a hot button political issue. Yes. Most recently, the vaccines that we had during the pandemic 2021, 2020. How can we non-scientists out there learn to appreciate science but not let politics sway our understanding of the process and the practice?
Yeah, I would tell everyone, politicians all have an angle because there's an agenda there. They have to get reelected. There's something that's behind their actions. In the context of science, I have no agenda, right? I want to answer the question to some important problem, but what the answer is, it doesn't matter to me, right? If I'm testing a hypothesis and it's successful, great. If it fails, great, because then I'm on to the next hypothesis. So ultimately, I think, when it comes to scientists, we are agenda-free. Most of us are just trying to do right by the public to answer really big questions to make sure that we all know more.
What's a really big question in science that you're hoping we come to and find an answer to in the next 15, 20 years?
Yeah, for me, cancer is always a big one. I don't know if we'll ever have a cure for cancer. If you think about how cancer works, right, it's kind of difficult to think about presenting it. But I think about, my mom's now a 10-year breast cancer survivor, right? That took a toll on her. And so I would love if we found a silver bullet for cancer. Mm-hmm. Yeah.
How often do other disciplines of science come in? Like you're working on organic chemistry. Do you often work with people who are in astronomy they come up to you, they may have found a new planet somewhere out there. They understand the chemical compositions, the makeup of the planet, and have a certain idea of what the atmosphere is like. How often do you work with those people in other disciplines to determine, hey, could this support life or not?
Yeah, man, that's every day. So there's atmospheric chemists, right? And I would say this is called interdisciplinary research. If you look at, Vanderbilt's a good example since that's where I'm at. Most people are in multiple departments, right? I'm a chemist, but I'm also in a pathology, microbiology, immunology department. I'm none of those things. I'm not a microbiologist, but I still have people in my research team that do microbiology. So we come together all the time to answer really big questions. And I think that's one thing that really, makes me back my car to the driveway every day is that I know a lot of chemistry, but I know very little about other areas of science. And when I go to work, I get to learn more about other people's research.
It seems like Vanderbilt is really making a push to invest in the sciences, to have groundbreaking research that could have effects on the world. What is it like to be a part of that community in that environment? Yeah,
it's phenomenal. When I got hired, the first provost who hired me was like, when you come here, you can't operate in a silo. Like, we don't want someone who's just going to be a chemist doing chemistry by themselves, not talking to anyone. And so I like this whole radical collaboration thing that we're doing at Vanderbilt, where it's just like, let's get uncomfortable, ask some very big questions that we really don't know how to answer, and then come together as teams to really like push on these questions. Yeah.
Last question for you. What do you hope people take away from this work that you're doing in studying chemistry, and particularly breast milk and the benefits of it, the hidden benefits that we're still discovering to this day?
Yeah, for me as the oldest brother of 3 sisters and the father of 2 daughters, and my husband and my mom, my grandma, right? I hope that people understand how important women's health and wellness is. When I first started at Vanderbilt, I always felt that like there was a war on women's health, right? Mm-hmm. Anything involving women became a hot button issue, and decisions were usually decided by rooms full of men. And so what I hope is that, we can step back and think about how powerful women are, right? What they're able to do for their babies and really for communities at large, and come away with a very pro-woman attitude.
Dr. Stephen Townsend is the Stevenson Professor of Chemistry at Vanderbilt University. Steve, thank you so much for being here. Really enjoyed this.
No, I appreciate it. This was a great conversation.
All right. Thanks to you for tuning in this hour. This is Nashville is a production of Nashville Public Radio. Today's episode was produced by Catherine Ceces. It was directed by Catherine Ceces. Our technical director and board operator is Liv Lombardi. The masterminds behind our theme music are LaRange and Namir Blade. You can listen back at thisisnashville.org or wherever you get good podcasts. And the conversation doesn't end here. Tweet us at This Is Nashville. Find us on Instagram. Tell us what you want from our show by filling out our quick survey online. You can also call and leave us a message at 615-760-2000. This is Nashville. I'm Khalil Ekalona. We'll see you tomorrow, everybody. And be good to each other.